Hello, everyone. Welcome to our live Q&A on the recent PyTorch 2.6 release. I'm Jennifer Bly, Marketing and Communications Director here at the PyTorch Foundation. I'm very pleased to introduce you to our speaker today, Nikita Shulga, who is with us to discuss what's new in our 2.6 release and answer your questions. We do have a few questions that already came in on social media that we'll address, but as you have questions, please drop them in the comments and we will have Nikita answer them. Nikita is a software engineer at Meta, where, among other things, he is responsible for PyTorch releases and continuous integration. Nikita is committed to uplifting the developer community and continuously improving PyTorch. He earned his master's degree in applied mathematics from the Moscow Institute of Physics and Technology. Please take it away, Nikita.
Thank you, Jennifer, and good time of the day to you guys. So PyTorch 2.6 was released I think roughly 2 weeks ago with more than 4,000 contributions from over 500 developers. So thank you very much for all your contributions. One of the highlights of the release, let me outline some of the highlights of the release. So with 2.6, we enabled the Torch compile support for Python 3.13. We extended the CUDA support to CUDA 12.6. We expanded ROCm to 6.2. We add the experimental support for CUDA on R64, namely Grace Hopper CPUs as well as Intel XPUs. Another thing that we're doing is we, as like standards and everything moving forward, we are preparing to migrate to more modern Linux runtime. So CUDA 12.6 will be the first release that uses something called Linux 2.28 standard. And so you finally can build your applications with C++11 ABI supports that will be supported natively by PyTorch. Another major change that you probably will notice is that in order to increase security, we want to load all the checkpoints with waits-only mode enabled by default. So if your model contains anything but waits, it will not be loadable and you need to modify your code. Another thing to call out is that we believe that the Anaconda PyTorch packages matured a lot since the time we started the engagement. So this release, we will not be releasing the separate Conda packages, but expect Conda Forge and Conda communities to build the packages for the users who want to have them. Other highlights include better AOTI inductor, which is like a new export path support for PyTorch. So there is a stable ABI that allows one to export once and run it, hopefully with the newer versions of the PyTorch runtime, as well as Triton operator library support for people who want to use GPUs and flex attention. And with that in mind, I don't know, I'm ready to answer questions. Okay, sorry. Is that correct to say that now PyTorch support for Metal Performance Shader is on par with CUDA support? If not, what is missing? Well, it is not on par with CUDA support, but it's striving to get there. So for those who don't know, the Metal Performance Shaders is a library that is available on macOS platforms that allows some compute acceleration on Apple GPUs or on Mac platform GPUs. And it could be used to accelerate PyTorch on the platform, but it is not as the support was added, I think, in 1.13. And on the other hand, if you think about it, the CUDA support was added in PyTorch 1.0 and even earlier. So yeah, no, it's not on par, but we are trying to bridge the gap. And if you want some feedback, please create an issue, or if you want to contribute, contributions are always welcome. Thank you. What's the next question? Rust programming language is getting more popular. Any plans to introduce Rust to PyTorch? I think you can use libtorch CPP with Rust if you choose to. But are there any plans to introduce? We definitely do experiment with Rust, right? Lots of PyTorch developers love Rust and write things in Rust. I think lintrunner, which is our linter solution, is written in Rust. But to fully replace C++ layer with Rust is a significant engineering endeavor, which hopefully we will undertake eventually, but I don't think that's something that we're ready to do right now. But again, we welcome the community input and contributions. So if somebody wants to write like a PyTorch extension in Rust, this should work. And if something doesn't, again, please create an issue and we will try to resolve the problems. Another little bit of challenge with Rust is like, if you want to use Rust, you need to ship Rust runtime, or you need to restrict what language features can be used. And I don't think we want to be like single-handedly define what should and shouldn't be used from the language specification. Next question, please. Does 2.6 have a natural support for leveraging AMX instruction on Intel CPU without the need for custom libraries? So some AMX support were added to a Torch compile solution. So yes, you can definitely benefit from that and through one DNN. So yes, but I think if you have some custom libraries that you relied upon, they should continue working with 2.6. But yeah, so like, I think it needs a little bit more concrete example to know what is missing and what not. Next question, please. How soon will PyTorch be updated for Blackwell with CUDA 12.8 support, as I needed to train on FP6 and FP4 support, and we have efficiency to get out of Blackwell. So first of all, Eli Riegas, who is an engineering manager at Meta, already answered it partially on X, but we do have an issue about enabling FP6 and FP4. I don't remember the issue number by hand, but you can go and check for it. So we do plan to add some support into 12.7. As of CUDA 12.8 support, we already have a nightly binary, so please check out PyTorch nightlies. And if something doesn't work, please report an issue. Next one, please. Will Blackwell be supported in 2.6? No, unfortunately not. So the release timeline between CUDA 12.8 and PyTorch 2.6 didn't really align with each other, and we don't backport features into stable releases. We do it not because of like some kind of a laziness, but because we want to ensure stable releases. So like when 12.0, like whatever PyTorch 2. something is out, 2.something.1 would be a patch release where it only fixes bugs and regressions from the previous release. It will not introduce any new features, even if we tempted to do so. So please try nightlies. And it takes time to kind of, like, it's very, well, not very easy. It's relatively simple to enable CUDA, but it's a bit harder to guarantee like a smooth transition and avoid any regression in any of the operator or compiler solutions. So this is why we take time to validate that all the features will work as expected before we say that something is ready. So you should expect like more Blackwell support in 2.7 release. Does 2.6 support JH200 with CUDA yet? Unclear from the docs. So I think, again, Eli answers this question on X, but yes, we do. We do not like promote it broadly because it is still an experimental support. We don't have like a full automated testing of the feature, but if you go to download.pytorch.org, like we'll CUDA 12.6, then if I'm, or 12.4, sorry, then if I'm not mistaken, you will find the R64 CUDA wheels there. And if something doesn't work, please file an issue. Next one, please. Are there any plans to update the data loader in 2.6, stuck with 1.13.1? That's a good question. I'm not, like, there is no active lots of active changes in the data loader. So there are some changes coming in 2.7, but like whatever's happening in 2.6 already shipped. But like if there is some problems, please post it in comment, like preferably with the issue number, saying, like here's an issue, something that I can use in 1.13 and which is totally broken in 2.6, and we'll try to address it if the problem still occurs on the supported platform. So if like you were using data loader on, say, I don't know, Pascal GPUs, and probably it's not something we will do. But yeah, if you were using data loader on Voltas in 1.13 and it doesn't work in 2.6, we should fix that. Next question, please. What is the relationship between AUTI and Torch Compile, and how users should choose what to use? So AUTI is ahead of time inductor invocation. So this allows Bond to create like a Python-free runtime for model inference or training, while Torch Compile just replaces your like Python function with a more optimized function, but it's still invoked within the Python runtime. But Torch Compile and AUTI use the same set of technologies, namely dynamo and inductor, to generate the output. But the difference is in the form of output being generated. Like AUTI output can be generated asynchronously and then loaded many times from a separate application. It can be Python application or like a C++ application. And again, in 2.6, we introduced a stable ABI promise that like if you export with AUTI and only use this like ABI compatible mode, you should be able to run exactly the same binaries that you generated with 2.6 and you like 2.7 or 2.8 releases. What should you choose? It depends on like how far are you in your development cycle. If you're still experimenting, I would definitely recommend just using Torch Compile. But if you have a model that you want to deploy for inference or training on many devices, then AUTI is probably a good choice. Anything else? Any thoughts from Torch Compile support for MPS Apple Silicon? It should be supported. There is an active development. So there should be some prototype version of Torch Compile for MPS in Nightlies, and there would be some support in 2.7. Like what would be the final form is still up for a debate, but you should be able to hopefully compile and accelerate your code on Apple GPUs using PyTorch. Next one, please. Any recommendation for someone who wants x86 macOS binary for fresh PyTorch releases? So PyTorch, we release PyTorch. PyTorch is an open source project. We release it, everything in the source form. So you can build it on your x86 machines and keep using it. You can create a community that will produce those binaries and try to use it. The reason why PyTorch x86 binary is no longer produced is because we do not host the hardware we build on. We like borrow it from the cloud, and it's harder and harder to get a performant macOS machines, x86 macOS machines in the cloud. I think we cannot buy a new one right now from the official producer. So this is the reason why we no longer build for x86 Macs, but it should be buildable. And if it's not, please file an issue. We should fix it. How can developers optimize PyTorch on ARM64 CPU, leveraging SVE, quantization, other kernel optimization using SVE? Is there any roadmap or a project plan? Okay, so SVE support for Torch Compile and Eager was landed and I think is available in 2.6 for ARM64. As for the roadmap, we partner with like hardware vendors. Like ARM is a member of the PyTorch Foundation, and they definitely working on to releasing something with the SVE support. So if you look at the pull request, you will see a lot of work happening with SV, and also like acceleration in the dependent libraries such as ACL, which stands for ARM Compute Library, and 1DNN. As for the roadmap, fair ask, we will try to coordinate and publish something. What are the big ticket features you see in PyTorch in 2025? That's that's a tough one, but I guess it's very much like PyTorch is big, so it very much depends on like what area do you care a lot. I think like what probably I personally, I think more data types and more hardware diversity is something that would be coming into PyTorch in 2025. So I expect users to be able to run their ML models on even more like accelerators than we currently support. That's a big thing in 2025. But that's a personal thing. Now, next question, please. An insight for the next big idea for PyTorch 3.0. Sorry, I don't know how to answer that one. Like, I can make some wild theories about like AI writing PyTorch itself, but that's a wild theories, and please disregard those. Next question, please. Any updates on using CXX11 ABI for PyTorch packages? I mentioned that in like my intro, that we introduced the first one, which is Linux. So a little bit of a background. So CXX11 ABI is something that's applicable only to Linux x86. The rest of the operating system already operate in the application binary, with application binary interface compatible with CXX11 standard library. But we do plan to migrate everything to Mini Linux 2.28, which is the first platform to be compatible with CXX11 ABI in the coming releases. I'm not sure whether 2.7 will be the one that breaks the boundary, but there will be more configs with 2.7 support. Next question, please. Hi, Jennifer. You're on mute.
Sorry, my mic was muted. Just wanted to give a notification for anyone out there who would like their questions answered. Please submit those now. We're going to close the queue in a couple minutes.
Oh, thank you. I think the questions that we just thought was the repeated one about MPS. Anything else? ABI stability for LeapTorch in the near future. So that's a great question. So the answer is twofold. Yes and no. So we want to create a subset. So what was started with AOTI, like stable ABI or ABI compatible version, will continue within LeapTorch. So there would be a subset of ABIs that is stable across releases. That probably has something to do with current dense tensors. But the full set of C++ APIs that is exported from LeapTorch will probably never be stable. Otherwise, it will be very hard for community to innovate and introduce new features. But there should be a stable subset of features available in 2.7. So stay tuned. Well, people working on the next question, I like to kind of reiterate. So right now, one should not expect an ABI stability, but like there would be some functions, some APIs that are C-like APIs and are stable. Any more questions? Any tips for people developing custom kernels for PyTorch? I think it's a little bit broad. I would like to know the architecture, but let's as a broad question, let's start with some help resources. So we have two forums. One is discuss.pytorch.org, which is for PyTorch users, and another is devdiscuss.pytorch.org, which is for developers. So if you want to like go and ask a generic question, people should probably answer that. If you want to develop for, say, GPUs, then probably we mentioned the StorShops Triton Ops, which is available for you, so you can write a Triton code that will be compiled and quite performant, and that could be hooked and used on either NVIDIA, AMD, or hopefully Intel XPUs. But for other like hardware accelerators, you probably still need to like use something like an A10, but also there is an initiative with the tensor subclasses, so you can implement your own tensor subclass and implement any kernels that you want there using any language of your choice. Please elaborate on backward compatibility with GPUs and supported GPUs. I assume that you're talking about NVIDIA GPUs. So, well, okay, so CUDA is backward compatible with previous generation of NVIDIA GPUs or current generation. So if you write a CUDA kernel for, say, Volta, it will run on Ampere or Hopper or Blackwell. So as for supported GPUs, we do support, well, it's again a little bit vague question. So PyTorch one should be able to run PyTorch on all the GPUs that is supported by CUDA Toolkit. But we do have a tendency to test more on, say, enterprise or Tesla GPU cards like A100, V100s, B100s, H100s, rather than like on a consumer GPUs like a GeForce 380 or something. But it doesn't mean it shouldn't work there. It's just like we have a limited ability to run some tests. We are interested in improving that area. So if you notice that something doesn't work, please create an issue. Or I think there is a Discord channel called GPU Mode that you can raise your question, which is more focused on like improving PyTorch experience on this kind of consumer GPUs. What are the challenges of benchmarking to avoid performance regression in PyTorch releases? That's a question I can talk for a very, very long time. There are numerous. First of all, how do you define what to benchmark against? So, like, as you know, you can benchmark operator performance. You can do like kind of an integration benchmark. So you can do an end-to-end benchmarks when you take a model and just run in PyTorch and measure the time it takes to run an inference, or like one epoch of training or something like that. The challenges are that, like, if you want to benchmark training, one epoch takes a long time. Another challenge, there are lots of models. We just can't test on everything, so we have to pick up few that is important. Another one is like getting repeatable hardware. So even if you get like two A100s, depending on the environment you're on, like two GPUs, right? Like, let's forget, if one GPU is in a really, really hot room and another in a cold one, the GPU in a cold one will be running faster than GPU in the hot one because of the thermal throttling and whatever. So that's a challenge in this benchmarking. Also data types and avoiding performance regressions. Yes, that's also a good point. So we do run nightly benchmarks when we collect. So if you go to hot.pytorch.org and go to the benchmark section, you will be able to see all the benchmark results. But the challenge there is that we run it nightly, and as I mentioned, like from 2.5 to 2.6, there was around like 4,000 commits. So it means that in a day we get roughly 100 changes to the PyTorch, but we run the benchmark once a day. So if there is a regression, the challenge is to identify which particular commit caused the regression. And it is especially challenging when this change fixes some functionality problem, even though it can introduce a performance overhead, which we have to kind of deal with. So we can't always go faster if code was fast but incorrect before. Next question, please. Which GPU architectures are best compatible with new PyTorch version? I don't, well, so that's a bit biased question. Like you ask what GPU architectures we test most right now in open source CI, and the answer would probably be A100s. But like coming new PyTorch, probably more and more hoppers and Blackwells will come. But like any NVIDIA tested GPU, if you're asking about that one, should be compatible. But there are other alternatives as well. Like there are, GPUs from other vendors that you can try. What is the best way to learn new features and more advanced PyTorch usage, in your opinion? You can read blog posts. You can read Ed Young's, you can watch Ed Young's podcasts when he talks about new PyTorch features. But yeah, I guess just engage with the community. And related to PyTorch, any thoughts related to UV? UV is great. It's faster than PyPy often. So people should use it. And PyTorch should work fine. But I don't have any strong preferences one way or another. I use VMs personally. Next question, please. Is there any plan to bring support for MPS sparse? We have huge potential for it with MPS, but not many things are yet in place. That's a great question. We looking for I think we cannot be expected to bring up all set of features on all platforms. But if you want to contribute something or have a concrete proposals, please file an issue, better create a pull request. But hopefully Torch Compile will help to bridge some of this gap when we don't need to write the same kernels by hand, but maybe can just compile some sparse support and use it. Now, next question, please. Hi, Nikita. I'm interested in functional collective. Is there any plan to improve support of this? Using PyTorch native functional collectives. You should ask the respective team, if you want to implement something or improve the functionality, and let me think about that. So if you think there's a demand from the community in general to use something like that, then please create a feature request and we will consider it. If you have a working prototype, then pull request is great. Or again, if you create a feature request saying, well, here is a prototype that does what I want, can you help me move it further? And then discussion can happen there. And hi, Piotr.
We have time for one more question. If anyone wants to ask one, get it in now. All right. Well, if anyone has any more questions, please feel free to ask those and we will follow up afterwards. Thank you so much, Nikita. Great Q&A time, lots of great answers. Thank you to everyone who asked a question. Please check out the PyTorch blog for more information on the recent 2.6 release. Also, be sure to subscribe to the PyTorch newsletter and follow us on social media on X, Facebook, LinkedIn, so that you can be the first to know about our upcoming webinars. Thank you so much.
Thank you, Jennifer, for the opportunity to speak about it. Have a good day. Bye-bye.
Bye-bye.